Hello friends, welcome back. So today I will be telling you very good stuff, and that is sorting in O(n) time complexity. Yes, I have achieved that, and I know that you will not believe it in the first go, but trust me, I have achieved the sorting in O(n) time complexity. And let's start that. So before going into that, I will tell you that this will be useful in practical scenarios, but not all the scenarios. But yeah, this O(n) time complexity sorting will work, and it will be really helpful in most of the practical scenarios which are densely distributed. So let's begin, and then we will understand this practical scenarios also, few of the practical scenarios. So so this is the input array 5 3 10 and 5 3 10 6 9 15 2 1 11 20. So what will be the output? So output will look like something. Sorted output will be 1 2 3 and then 6, I will say. Then I will say whichever, sorry, 5 is the next value, so 5 I will say, then 6 I will say, and then 10 I will say, 11 19 and 20, right? So output will look like this for the above sorted array, above unsorted array. So how we can sort this is through the number system. So what I wanted to have something is like number system. So let me draw it for you meanwhile. So yeah, I am drawing this on number system. So how our brain work is internally, what I think is it could be different for every individual, but mostly how it will do is it will start putting it in the number system internally. So 1 will come here, then 2 will come here, then 3 will come, then 5 will come, and then 7 8 or whatever the next value is there, 6 is there, 6 will come, and so on. We will keep putting the things on the number system, and for those where value is not present, our brain will simply shrink those values. Like 12 and 13 is not there, suppose it's not there also, so it will simply ignore these values, right? It will simply crush these values. So I've just put it all the entries on the number system, right? And that's what I wanted to do also programmatically. So how I thought is just how we can achieve that is what I did is I built an array, and let's 0 1 are the indexes, 3 4 and 5 6 7 8 9 10 and so on. Okay, so what I did is I started scanning into this. So 5 came, right? 5 first element is 5. So what I did is array dot 5 is true, is equals to true. So I put here 5 is true. Then 3 came, array dot 3 is equals to true. So I put 3 true. Then what I did is array dot 10 is equals to true, and so on. So 11 12 13. So what I did is 11 is equals to true, so let's mark it as also true. And then 6 also true, then 1 also true, so on. So what I did is I put all the input elements. So 5 is the input, so I put on those indexes the value is true. So I am making this array as a number system array. So this array is marked as a number system array. Now what I will be doing is I will iterate on this array. So 1 is true, yeah, 1 is true, so I will put that value. 2 is true, yeah, 2 is true, I will put that value. 3 is true, yeah, 3 is true, so I will put that value. Similarly 5 is true, yeah, 5 is true. So this array will become like this array. So let's start with this algorithm. Algorithm is quite simple, and it will work very fast for most of the cases. Yeah, I will share this idea with the whole community, and if this is not getting used in the market already, definitely it will be very helpful in most of the practical situations. Most of the practical situations, like where densely distributed system like 4,000 peoples, and we want something sorted related to, or 5,000 stores, or even lakh entries also there, but we should aware about the max entry. So I will try to improve this solution further, so that the infinite space complexity can reduced, could be divided into further chunks also, definitely. And there could be then pagination kind of thing, indexation kind of thing, which can be brought into the picture, similar to the pagination. And this sorting technique can really work faster. So for this scenario, it's simply working in ON case. If we know the upper limit and our memory is feasible, this will work in the ON time complexity. So let's jump into the solution. So I have already wrote the code for this. Yeah, so just 2 lines code. As you know, the solution was quite simple. What I am doing is just created a sorted list, and in the sorted list I will just part the unsorted list, and the sorted list is the answer. So in this function I will just pass the unsorted list. So now I have created here for only 25 elements. I assume that the upper limit will be 25, since I told it's for the practical purpose. So I'm assuming that we know here the upper limit is 25. Then number list, I will just iterate over the number list, and if the number list is just a dummy array, and it will just put the value true. So it will put at 4 value equals to true, it will put 2 value equals to true, 8 value equals to true, and so on. And then what sorted list will do, sorted list will check if value is 1, it will add, otherwise it will not add, and simply it will add that index. Note, it is just adding that index. So hope the solution is quite clear, very simple, very straightforward, just iterating over the indexed array or the number system array, and I will better say number system array, and then it will add where the value is present, it will add that index, and then it will return the sorted list. So I can run this, and I have already, so it will be very fast because it's just on time taking complexity. So let me show you the output as well. So see, 2 3 4 5 6 8 all are sorted. I can do it, we can take for minus as well, that is for sure, but I have not written that. We can do that for sure. Let me do some modification. Let me put 14, and that let me put, so I know that my range is still 25 only, so let me put 17, let me put here 9, and again run it just for the testing purpose. So, and what I'm calling is unsorted list, array.sort list. This sort list, array sort, this is array sort. I'm marking it as a sort, or I will prefer to rewrite it as a number system sorted algorithm, sort list. And what it will do, it will take this input 4 2 8 9, and it will just give a return output with the sorted array. Let me run it. Yeah, 2 4 5 8 9 10 11 14 15 16. So it's working very simple, very fast, and very robust, and it will be useful in many practical scenarios. Thanks, and have a good day.